Hello, in this video we're going to do checkpoint 5.22. We have a double integral of e to the minus 4 times x squared plus y squared dx dy, you can just call it dA, over the region R. Actually, not just the region, but the whole xy plane. We're looking at the whole xy plane here. Alright, this looks like it's going to be an improper integral because you're going to cover the infinite plane. And the key to look at is that, hey, this is an x squared plus y squared, so it might be a good idea to go into polar coordinates. So imagine in polar coordinates, your R, we can imagine R going from 0 to as far off as we want. So this is infinity, going from 0 to infinity, and theta, well, theta does not need to go all the way up to infinity, because if you just go from 0 to 2 pi, then you would have covered everything you want to cover on your xy plane, because you're just going to let R take care of covering everything else going to infinity. Okay, so let's write infinity a little neater, and that's how your limits become improper. The other thing is that you can't take the integral of e to the negative x squared, but if you do the replacement for r, your dx dy will become r dr d theta, and then you'll have an extra r that pops up. So here's what we have: an integral e to the minus 4 r squared. This becomes r squared, and remember, you can't just take the integral of this with respect to r, but our dx dy will become r dr d theta. And so we put in our limits. Let's put in our theta limits first, going from 0 to 2 pi, and now let's think about what r is. R goes from 0 to infinity, and instead of infinity here, to actually properly treat this as an improper integral, let's take the limit as b approaches 0 of b as the limit there. I'm sorry, b doesn't go to 0, b goes to infinity. So we'll take the limit as b approaches infinity of this expression. Okay. I don't see any thetas inside of the integrand, and these are constants, aside from that weird infinity, and so we can separate this and just have the integral from 0 to 2 pi of d theta and treat that separately. And then now let's focus on the limit as b approaches infinity of this integral, and this is e to the negative 4 r squared r dr. Okay, now as we focus on this r squared r dr, let's do a u substitution. U is equal to negative 4 r squared du. It's going to be negative 8 r dr, and so the r dr here gets replaced with negative 1/8. So this will be an integral of e to the u times negative 1/8, and we're gonna go from 0 to b. These are still r limits, even though we're in u right now. So the antiderivative of e to the u is just e to the u, and we'll replace that with the substitution that we made, which is negative 4r squared from 0 to b, and then we'll put b in there. We're going to get negative 1/8 e to the negative 4b squared minus e to the 0, so that's a negative 1/8. E to the 0 is just 1, so this becomes a positive 1/8. And if we take that limit as b approaches infinity of this expression that we have, negative 1/8 e to the negative 4b squared plus 1/8. If we take that limit, this is just going to go off to 0, because infinity, e to the minus infinity will go to 0, and this will just leave us with 1/8. Okay, remember that we got 2 pi for this, and so your final result is 2 pi times 1/8, which is going to be pi over 4. All right, I hope that helps.